Here's another application requiring high sensitivity under bright light received conditions. Here we have a metal can, and I've taken the liberty of drawing an arrow that runs widthwise to this can. And the reason I did that is because there's a brush pattern that runs widthwise to this can. Now on this enamel can, we have a different situation. The brush pattern runs lengthwise, and I've drawn the arrow to indicate that. Now let's see if we can identify which can is which by responding to the orientation of the anodizing or the brush pattern on the can. Here we have the can where the arrow indicates the brush pattern is running widthwise in this direction. What's happening here is the fiber optic sensing tip is pointed at an angle, so the light goes down into the pattern. Because it's running crosswise to the light pattern, sends the light right back into the face of the fiber optic sensing tip. And you'll note we have a 10 on the contrast indicator. Now if we move this can out of position and locate the enamel can with the different orientation, and by the way, we're not responding to color whatsoever. This is strictly pattern recognition of the direction of travel of the brush pattern. Now you can see by the arrow that this brush pattern is running lengthwise. Now the light's coming out of the sensing tip, striking the can and bouncing off of the angle of incidence. And there's a 10-bar deviation. You'll see we're at 0 on this can, and when we bring this can in, we go back up to 10. Now the interesting part about this is if I move this can and I turn it, you can see it is responding to the direction of the brush pattern. Now as long as the pattern remains the same on the enamel can, and it's 90 degrees out of direction with the anodizing pattern or the brush pattern on the silver can, then we can identify cans merely by the orientation of the brush pattern. The varnished can versus the unvarnished can. Let's look straight down at the can with the fiber optic light guide and see if we can sort these by color and color alone. As you can see, we have a 10 on the unvarnished can, no problem whatsoever. By the way, the brushed surface has nothing to do with this capability. As you can see, if I turn it, it doesn't matter. It simply stays at a 10. Now we'll move the enamel can into position and see the results. As you can see, we get 0. So we're getting a 0 on the varnished can versus a 10 on the unvarnished can. Prior to the availability of the Mark II sensor with the blue LED light source, this sensing task was impossible.
Thanks for watching. For help with an application or for more information on this product, please call Tri-Tronics or visit our website at the link below.